last time? Okay, if we have our Cartesian plane like this, and then we have a certain curve from A, that is moving from A to B, okay, our formula for the length is equal to integral from A to B square root of 1 plus f of x, that's f prime of x squared, yeah? And then this is dx, right? Okay, what's the formula do here in this curve, okay? So if we are going to, let's say, maximize this one, not maximize, magnify, okay? If we magnify this one, what's happening is we get a portion of this, right? We get a portion of this, and we will have like a single point on the line. So since it is like under a microscope, okay, that's a single point, that part, okay? And then this point is now going to be traveling using this path, okay? That's now our function. So this is going to be traveling, just imagine that it will be traveling like this from A, that's the A point, until the B point, okay? Can you imagine what I'm trying to say here? Yes? Okay? Now, why is it just a point? Because what we did here is we get the x, okay? We cut it and then let x approach 0, meaning that is just the dx. So the dx is actually just the width of that point, that single point, okay? It's just this. Clear? That's it. This is now our dx. From here to here, it's our dx. Since we projected this one as x approaches 0. You understand? So what we did is we just get 1 point, and then when we evaluate it from A to B, we are just dividing it equally using now the diameter of that point in E. Understand? And then since we evaluate it like from A to B, right? So it will now become plus ini, plus ini, plus ini, plus, 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 plus. That's the reason why you will be able to get the length of the entire line. You get the idea? Okay? So that's how it is. Now, if we take this idea a little bit further, okay? If we take that idea a little bit further, if let's say I have a function y equal to 4, let's do y equal to 2, okay? Y equal to 2 is somewhere in the y-axis, right? Correct? So if this is 2, if that is 2, then y equal to 2 will be found here. That is y equal to 2. Correct? Now, if I do this, that is 4, okay? And I'm going to draw a line at 4. Let's just use a straight line. What area? How are you going now to calculate for the area here? Area is equal to, let's just go back to basic geometry. What's your area? Anyone? Area is? I cannot understand. Come on, speak.
Length times width.
Length times width. Yes. Oh, you are laughing. Yeah. Okay. Length times width. That's correct. Yeah. SMT1. Okay. Lesson. Length times width. But what is our length times width there? That is now area. You read the Cartesian plane or you read the graph. So it will become what?
4 times 2.
4 times 2 or 2 times 4. And area is basically 8 square units, SQU. Okay? Correct? Yes. Okay, so what if I'm now going to divide this one like this? Effectively dividing the area into 2, correct? Yes. So to solve this one, it's area 1, okay? Area 1 tamba area 2, correct? Yes, okay. If I cut it lagi, what will happen? Area 1, area 2, area 3, area 4, tamba semua, correct? Okay. Now imagine that I'm going to cut a very thin piece of that, a very thin piece, wherein the x value now approaches 0. Okay, a very thin piece that so that the x distance is approaching 0. That means this part, I am trying to get a width of dx. I want to get a dx out of that because I'm getting it closer to 0, derivative in x. So if we magnify that one again, if we magnify it, okay, what I will get is what? I'm going to get something like this, right? And this is now the x-axis. This is now the y-axis. This is now our function over there. That is now y equal to, it was magnified. But this one is our dx. This distance that we have here, this one is what? This length is what? From the given, it is
2.
y, correct? From here to here, this is now our intersection, that is the origin. So this is now y, correct? Got it? What's the area of this small thing? Area ini apa?
Y times dx.
Y times dx. Y times dx. Area is equal to y times dx, correct? Now, what will happen just like this if we project it from 0 sampai 4? If we evaluate this one from 0 until 4, that means we are trying to say that we want to cut it. You use the dx here, 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 until here, and then add everything, right? Correct? Yes? Just like what we did with the line. But this time we are not adding distance. What we are adding is area. Area plus area plus area plus area plus area. Correct? Yes. So instead of writing it like this, I can now write area as what? Area is equal to length times width. Length times width. But then we evaluate from 0 to 4. So you can say A to B of y can also be written as f of x kali dx. Okay? Do you agree? Do you think it's logical? Do you think it's possible? Let's test. Okay, let's test. Before you agree, let us test it on this. Okay, so we should get 8 square meters, right? 8 square units. So area is now going to give us from 0 to 4 of what is our function? Our function is 2 multiplied by dx, correct? So this is now going to give us what? Area is equal to 2x evaluated from,
0 to 4.
2 to 4.
so area going to give us upper limit
units.
minus lower limit. So you will still get 8 square. Take note, this is length times width. So it is going to be square unit. Okay. Yeah, that's correct. Okay, so this is now our area. So the question now here is a lot of you will be saying, teacher, why do we need something like this? Because I can just read it. See, I can get 2, I get 4. Very easy for me to read it out. Then why do we need such a extreme formula to get to use integral for an area? Okay. Well, this is not limited to a straight box or a straight line like that. Okay. If you have like something like a line like this, okay, and then we are going to get from A to B, then we can get a certain area like this using this, correct? As long as you know this function. Yes, correct. But some of you will say again, teacher, why will I still use that? I can just use cutting. I can cut that as triangle and rectangle. Yes, okay, that is acceptable. Okay, but what if I am going to give you now a curve from A to B? Okay, if you are now working with a curve from A to B, it is still possible to get that area inside the middle. Okay, clear? There. So we do not have enough time, okay, but I want to direct you to your textbook, page 127. Okay, the textbook presented a similar explanation to what I said. Okay, it's 127, page 127 of the textbook. But I want you to move directly to 134, page 134. On page 134, with this information that I have given you right now, with this formula that I have here, we can actually solve 1A. You can actually solve 1A already on page 134. Area given there. You can check your answer by using the cutting method to double check. Okay, you can read that one. You can double check your answer by adding area 1 and area 2. But you do this one first. Use the integration first. Okay, clear? Okay, with that said, you can now move to your next class. Goodbye, everyone.
Goodbye, thank you, teacher.
Goodbye and thank you, teacher.
Thank you, teacher.